Well, welcome everybody. Appreciate you coming out today. And thank you to INN Labs for hosting and letting me totally hijack their office hours. This is Code Review for me and you. My name is Steve Grunwell. I'm at Steve Grunwell on all the social networks that matter. If you're the kind of person who likes to follow along with your own copy of the slides, you can get them at stevegrunwell.com/slides/code review. I'll also be tweeting this out afterward, and I'll make sure that the recording gets bundled with a copy of the slides. First, a little bit about me. I'm a senior software engineer at a company called Liquid Web. We're a hosting company based out of Lansing, Michigan, though I'm the only Ohio employee, which is always really fun if you know the Ohio-Michigan rivalry stuff. I work primarily on the managed WordPress and managed WooCommerce hosting platforms. I'm an open source contributor, albeit a lot of that comes out of using a lot of open source software, subsequently breaking a lot of open source software, going, oh crap, oh no, oh, this is the end of the, oh, hey, that's not so bad. Someone should really write that down. I'm a husband and relatively new father. I have, I guess it's not even that new anymore. She's coming up on 3 in September, but I'm not going to be one of those parents that's like, oh, let me put pictures of my kids throughout the slide deck. That's, oh, Emily, you scamp. How did you get in there with your grilled cheese? Which, by the way, I am at home right now, so if you hear screaming, that is aforementioned toddler. I'm also a home coffee roaster. I've been working on predominantly distributed teams since 2014, and I'm a huge coffee snob. And if you're really into like craft coffee and you work from home and you don't have an office providing it, it gets really expensive. So check out my blog if you're interested at all about roasting your own coffee, but we're not here to talk about coffee. We are here to talk about code review. Now, before I can tell you all the reasons you should be doing code review, it's really important to understand what the term means, because it can mean different things to different people. And the way I see it, code review can take a few different forms. First, you have the formal code review. This is going to be an official part of your team's development workflow. Something where every major change gets reviewed before merge. So your workflow might look something like, oh, development in a branch, code review, then merge it in. If you are on a team that's doing pair programming already, you're essentially already doing this on kind of an implicit level, because you have someone looking over your shoulder, seeing what you're doing, you're discussing things, and it's going to offer a lot of the same benefits. But code review can also take the form of, say, bug sweeps. This is going to be where larger chunks are reviewed after merging. Maybe you're approaching a release and you're like, let's really go back through the code base. Now that we have all of these small pieces, make sure that they've come together in a way that makes sense, kind of that bigger picture perspective. There's also more informal code review. This is where code review isn't necessarily going to be a required part of your workflow, but instead it's part of your team culture. And informal code reviews can actually, as a result, be some of the best learning opportunities when you're not restricted to just oh, we can only collect feedback at this time, but rather anytime I kind of have a question, I can, poke my head over the wall or knock on someone's door, or send them a message on Slack and say, hey, you mind taking a look at this? So these can be some more ad hoc check-ins, but they can also just be kind of questions of like, hey, I'm about to go down this road, and before I spend too much time in this rabbit hole, can you kind of gut check and make sure that I'm on the right track? One tricky thing about a more informal code review culture is that it does require a culture of respect. If you have competitive types who kind of go, no, I never make mistakes, I don't need people to look at my stuff because I'm perfect and everyone else is terrible by comparison, that's going to be really difficult to pull off. But if you can bring a little humility to it and you can kind of know, this is a good time to sort of ask for help, get some advice, get a second set of eyes on it. This can be a really effective way without adding a lot of kind of overhead. So some of the value that we derive of code review, it may be apparently or immediately apparent, but regular code view also carries a lot of value that some teams aren't going to recognize until they've been doing it for some time. So some of the things that we can get out of code review. First of all, first and foremost, software bugs. They're like Pokemon. You've got to catch them all. and 2 sets of eyes are going to be better than 1. This is going to help you catch some of the most egregious errors, the things where, you know, oh, I wrote this code, but I didn't actually run it, and now I can see, you know, semicolons are missing. We have syntax errors, or we have vulnerabilities with unescaped SQL. It's going to be focusing more on the low-hanging fruit. Now, this low-hanging fruit, these are also some of the easiest things to automate away, and we'll take a look at how to do some of this later on. Code review also helps us catch some of the larger architectural issues. Now, this does require some familiarity with the code base. You can't just, you know, pluck a random member of the team who has no idea of, no understanding of the domain of the application to then say, hey, look at this and tell me what you think. They're going to be able to go, well, this is technically incorrect, you know, PHP, but they're not going to be able to kind of know all of the little edge cases, all of the how it fits into the big picture. But if you have someone with that domain knowledge and they've ramped up a bit, this is where code review is really going to start paying off. It's going to be your first line of defense against technical debt, and it's going to help you catch duplicate logic, duplicate functionality, things that aren't, you know, dry. If you have really convoluted data flows, or if someone's able to come in and say, hey, every time you need to test this thing, you have to like scaffold like 5 different components of the application in order to try to, you know, is there a way we can simplify this? If they're familiar with the particular framework or just the application as a whole, if you're doing things like re-implementing database access logic, if they're like, hey, there's already a method in our data access layer, or, you know, hey, did you know the framework or the library that we're using, it already has this functionality. Were you aware of this function? They're also going to help keep you honest and make sure that you're not just reinventing the wheel, because we as developers like to solve problems, whether they've already been solved or not. Code review can help to reduce the so-called bus factor. If you're not familiar with the term, the bus factor is the cost to your team or company if the one person who understands a code base gets hit by a bus or otherwise leaves the team. It doesn't have to be a violent thing like getting hit by a bus. It could be this person just went on parental leave, or this person, you know, took a promotion and got moved to a different department, or this person just simply does not have time because they're so overwhelmed with other things. The more people who are at least familiar with the code base, the lower your general risk. We don't want our code to be developed in a vacuum where only one person understands it, because that's just asking for trouble. Another value of code review would be developer growth. Code review is, of course, a great way to help developers continue to learn and grow. It's a great way to help junior developers. If you have a senior developer looking at a junior developer's code and saying, hey, you know, I see what you're getting at here. You might want to look at documentation around this term because it sounds like, let's say it's a singleton pattern. The junior developer might not know the term singleton, so they might not know how to look for that, but it's like, hey, you're trying to make sure there's only one instance of this object. Take a look at literature on singleton patterns. Conversely, we can flip the table, and it's a great way to help senior developers grow. After all, reviewing senior developers are going to help keep them up to date. Yesterday's best practice is tomorrow's anti-pattern. So if someone's been doing, you know, well, this is the way I've been solving this problem on applications for the last 15 years, and it's like, yeah, but now there are better ways, or, you know, you're doing the really long roundabout way that was kind of a hack 15 years ago, but now there are much smoother, more elegant ways. When dealing with reviewing senior developers' code, I'd also strongly recommend getting juniors involved. This can be a great way for a more junior developer to kind of see, okay, this code is supposedly what my company considers to be senior level code. So they can kind of look and see, oh, okay, so they approach the problem this way, and oh, I am not familiar with that piece of functionality, and I've never seen code structured like this. So it can be a good way to ask questions and start a good conversation to help both the junior and the senior developer grow. So in short, who should be performing code review? everybody. There's too much to be gained through review to limit it to just seniors reviewing juniors' code. No two devs are going to have the same experience, and outside perspective can bring a lot to the table. Additionally, the review is going to show the reviewer the thought process, which is insight into the developer's mind. If you just have kind of one giant commit of like, oh, built this feature, and you can't really see how they tackled the problem, you just see the end result, that's not as helpful as if you were able to kind of really see, okay, these are some of the steps they took, whether they were missteps or whether they ended up working out, and see how this developer thinks. In the interest of presenting both sides, there are some pretty valid arguments against code review. I'm personally super for it, but these are some scenarios where maybe code review isn't going to make a whole lot of sense. Good code review does take time, and the larger the review, the more uninterrupted time is needed. If you have constant deadlines and you just, you can't afford to take a break to, get a fresh cup of coffee, chances are code review is going to be burdensome. People are going to be resentful about code review. It's going to be just another thing on the pile that they have to take care of. And they're not going to see it as a good learning opportunity. That can lead to the code not being earnestly reviewed. If it's just kind of well, if I don't code review this, I'm going to get yelled at. So I guess I'll look at it quickly and say, yep, doesn't seem to be anything like super terrible. So let's call it good enough. If that's how code reviews are being approached, they're not code reviews, they're a charade, and therefore a waste of your time. Conversely, you can get some people who are just a little too into reviews, where it's like a 4-line documentation change, and the review comes back with like 8 different comments and lines that need changed, and it's just super nitpicky and not particularly helpful. If you find yourself saying, well, that's not how I would have done it, and that's kind of the extent of your feedback, that's not going to be a particularly effective use of your time doing code review. So I recommend building a culture of code review on your team. The best way to ensure code reviews get done is to make them a part of the workflow. And this doesn't necessarily mean that it has to be a formal thing, but in kind of making it, well, we try to make sure that everyone is consistently reviewing code. The more frequent you can make it, the less of a dreadful, oh no, I wrote this, I think it's great, but it still has to go through the dreaded code review. So make it part of your team's workflow. Empower every member of your team to be able to request a review. Don't make it, oh, well, we can only have reviews at these given scheduled times. And, only a manager can say, yes, this code must be reviewed, or no, that shouldn't. Empower people to be able to ask questions, to collect feedback, and to continue to grow. It's too good of a learning opportunity to pass up. And next, no shortcuts. If you are in that hypothetical situation where we're constantly shipping stuff all the time, we don't have time to review it. Or if you're in a hotfix scenario where something is broken, we need to get this out. It's more than just like, oh, there's a syntax error that took down prod, but rather, we need to add this feature because it's super important. Try to avoid taking shortcuts. If hotfixes need to happen, that means you need hot code reviews, or well, that's not as great a term. Let's just call them emergency code reviews. You shouldn't be skipping the process just because you're in crunch time, because that's when you're most likely to run into errors. So if it's not important to review, perhaps it's not important enough to ship. When dealing with code reviews, please remember, it's not personal, it's strictly business. Code reviews are meant to help you improve this code and grow as a developer. So as tempted as you may be, please don't take or make code reviews personal. This is not the time to take out your aggression against that person on the team. This is peers helping peers, juniors helping seniors, seniors helping juniors, however you want to structure it. Become better developers and ship better software. Likewise, We want to try to avoid code ownership. Sometimes if you've been working on something, especially for longer periods of time, you may become very attached to this code. This is my baby. I've been working on this for days, weeks, months, whatever. When you're being reviewed, it can feel really easy to kind of feel like someone is saying, well, you have a really ugly baby. And that's not going to be helpful. So remember that code review is a compromise. The code itself, while you might have people who are responsible for particular pieces of code, the code is owned by the team or the client or whomever. And review is a compromise to reach that best possible solution. So there's a lot to take in. When I'm approaching a code review, I find it's typically easiest to break it down into 3 priority levels. First, does the code do what it's designed to do, and or does it break anything else? So in short, does it work? Does it do what it says on the box? Next, does it work well? Are there potential security or performance issues? This is going to be where you're going to catch things like, are we escaping our output properly? Are we sanitizing our input properly? If you're doing WordPress forms, are we using nonces and everything here? Are we doing this, quote, well? And then finally, does it adhere to our coding standards or other rules? If I get a code review assigned to me and someone says, hey, can you take a look at this? And it's using spaces instead of tabs, that is a much lower priority than, hey, you're not actually sanitizing user input and thus putting our entire application at risk. So I found that this priority listing, does it work? Does it work well? Does it meet our standards? Tends to be a good approach as you go into a code review. So let's talk about what it looks like to give a code review, particularly an effective code review. So if we can agree that there's worthwhile value to be had from regular code review, let's talk about how to make each one get the most bang for our buck. I'm going to look specifically at the GitHub pull request model. This tends to be very popular on teams. There are very similar models available through Bitbucket, Beanstalk, GitLab, any of the major source control applications. But GitHub tends to be a rather familiar thing, so we'll use them. Now, our general workflow is going to look something like, I'm going to, as a developer, push a new branch. I'm going to open a pull request, commonly shortened to just PR. If we're using any sort of continuous integration tools, if we're running our unit tests on Travis, or if we're running Code Sniffer or anything, and we'll talk about some of those tools in a little bit, we're going to do that automatically once the pull request is opened to kind of catch some of that low-hanging fruit. Then a reviewer is going to go in, they're going to leave feedback, and then if everything looks good, we're going to merge. So walking through those steps, we push our branch. I've done all my work on, in this case, fix/mybugfix. If you're not doing branch development, that's a talk all in of itself, but definitely look into it, because if you're just doing everything on everything on master, code review can be a real difficult thing. So I've pushed my branch on GitHub. I can then compare branches and I can say, okay, I want to merge develop into master in this particular situation. I think people can see my cursor. Yes, maybe. Yes, sweet. This is even better than a laser pointer. Webinars are sweet. Okay, so we're comparing develop against master. It's telling me, hey, we're able to merge. I've got this big green create pull request button, but I can also see there are 5 commits. A total of 1 file has changed. There are 3 people who have contributed to the differences here, and you can see each of these commits. If we scroll down further, we can actually see a line-by-line comparison, which we'll see in a moment. But let's say we click this big green create pull request button. It's going to give us a UI very similar to the issues UI, where we have a title and a description kind of saying, hey, this is what's going on in this pull request. So we open the pull request, and come to think of it, this is actually a live pull request that I think is still open on one of my repos, because I'm a bad open source maintainer. So Rowan here opened this PR and he says, oh, this speeds things up about 4 times. I'm assigned as a reviewer on it. And so I can come in here and I can say, I want to add my review. This particular repository isn't using any continuous integration stuff because unit testing bash is not as straightforward as I hoped it would be. But if we were, this would be the time to do things like run automated test suites. If we want to check coding standards, make sure that everything kind of matches up against the standards we've declared for the project. If we are writing tests for it, we can calculate code coverage, kind of figure out, are there areas of this application that we haven't really touched at all with our tests? So we'd execute that at this point. But again, with this repository we're using as an example, CI isn't involved. So we come back here, I click the Add Your Review button. We get brought to a screen like this, where it gives me this nice little modal that's like, hey, you want to submit a summary, and you can either comment, which is submitting feedback without an explicit approval. We can approve, or we can reject/request changes on the pull request. But if we dismiss this, we can see actual line by line, all of the pinkish red. These are lines that have been removed. The green are lines that have been added. We can click on individual line numbers, and we could say, oh no, if I happen to remove this comment, the entire app will go boom emoji. And then I could choose to either add a single comment, which will immediately email the person, or I can say start a review, and it'll kind of queue them up. And then when I'm done, I come up here to review changes. I can either approve or request changes. And then if I've started a review here, it'll send out all of those emails as one, rather than sending 17 individual emails. We get one email with 17 comments, which is much nicer. So as I mentioned before, some of the other popular tools for this, if you're using Bitbucket, GitLab, Beanstalk, Fabricator, any of these, they're going to have a very similar workflow. This is kind of the comfortable pull request workflow for the modern development community in 2018. Providing feedback on our pull requests. This is kind of an art form all in of itself, and especially if you're tackling a large pull request, it can be kind of overwhelming. Well, where do I focus my attention? How do I provide feedback without just coming across like this pompous ass? Because as a general rule, you don't want to be a pompous ass. So in your feedback, as much as you can, try to be objective rather than subjective. Rather than focusing on that, well, that's not how I would do it. Try to provide actionable things that people can actually learn from. When you're citing, quote, best practices, don't just say, well, based on best practices, it should X. That's not particularly helpful. And best practices can be kind of subjective in their nature. So if you can provide resources, if you're building a WordPress site and the WordPress.com VIP best practices state, hey, for secure, scalable, performant WordPress sites, you should be doing this. If you can provide a link to that documentation, that helps strengthen your argument. It makes you not the pompous ass, but the person who's able to inform somebody, and gives them a jumping off point if they're kind of like, wait, I don't understand. I've never come across this. And then they can kind of read more. But you're giving them that push in the right direction. And if in doubt, this is a little trick I picked up a few years ago. If you're not sure about something, or you don't really agree with how they approached it, maybe try asking questions. Rather than just kind of saying, hey, this is wrong, or even, hey, this is wrong, look at all this documentation, why, you can kind of take them off the defensive by instead asking, hey, interesting approach here. Is there a reason you chose to do it this way rather than this way? Or when we've built things like this in the past, we've used this pattern. Is there a reason you opted to use this pattern? That can have two major effects. First, it can make the developer kind of go, oh, you're right. I approached it that way just because it seemed like the right thing to do. But now that you mention everywhere else we're doing it this way, that makes more sense. Or you can get the person to kind of have to really explain their thinking behind it. Either way, you end up with more context, more information that historically will help your project. If someone's like, hey, why did it get written this way 2 years ago? And you can go back to the pull request and you can say, oh, here's this whole conversation where we've kind of implicitly documented why this architectural decision was made. It can be rather helpful. So some examples, a not so great one, and I need to, let me get my pompous asshole voice on. If I were you, I'd move this function to the widget class, so it's not so hard to find. Ugh, I want to punch myself after saying that. Now compare that to something like, it seems like this function is closely related to the widget class and not used anywhere else. Would it make sense to move it into the class instead? You're providing a suggestion, but you're still deferring to, hey, you're the person who wrote this code. Here's a suggestion. Does it make sense, or am I missing something? That's a good way to kind of lead into a conversation and avoid taking the I know better than you standpoint. Another not so great example. Output should be escaped. Great. That's super helpful. And if someone hasn't dealt with like late escaping output, they're going to be like, I don't know what this means. Compare that to the output of this HTML should be escaped via escape attribute. You'll notice escape attribute on my slides is blue because it's a link. I chose to link directly to the WordPress codex for the escape attribute function. So if someone's not familiar with escape attribute, they can go there directly. If they're not familiar with escaping in WordPress in general, they can kind of go, oh, I didn't realize there was this whole series of functions, and this is what they do, and this is why I should use them and when I should use them. Again, providing that leading off point that can help your developer grow without you having to explicitly like write out a giant document about these are all the reasons why we late escape. When you're leaving your feedback, also make sure that you're not just focusing on what was done wrong, but what was done right as well. Celebrate the small victories. These would be comments like, great catch. A lot of people would have missed that condition, especially if you're dealing with a really complicated application and you happen to notice like, if I was doing this, I totally would have overlooked that, had a bug, it would have been a whole big thing. Congratulate people, give some positive reinforcement for the things that they're doing well. Likewise, where did you learn about this function? It's super useful. This is great if you have people who are definitely trying to dig deep and have really broad knowledge of like all of the different tools available to them. This is a nice way to kind of subtly acknowledge like, hey, you've been doing your homework and it's definitely paying off. Well done. You've come a really long way in your use of caching. Well done. Maybe you did a code review for this person a few months ago and they were dealing with a lot of like expensive queries that weren't getting cached, and it was, kind of, you were pulling your hair out before, and now you're noticing that like, hey, you're improving. Like you took my advice and our discussions earlier to heart, and you're continuing to grow. If you are mentoring a more junior developer, this is a great way to get them go, hey, look, I've been noticed for all the hard work I've been putting in. And also shows that, you have an existing relationship rather than just, you're someone off the street kind of reviewing this code. And finally, things like this documentation is excellent. Thank you. Because if you write documentation, you damn well deserve to be thanked for it. Far too many, or far too few of us rather, write good docs. So please do that. Now we get into some of the advices from the trenches. I've been doing code reviews pretty regularly for the last, 4 years now, which is kind of mind-blowing. But here are some of the best things best piece of advice I've picked up. First, practice atomic commits. If you're not familiar with the concept of an atomic commit, each commit that we make to version control, whether it be Git, SVN, Mercurial, any of them, should be small and focused, touching as little as possible. Commits, especially in a system like Git, are super cheap. So don't be afraid to commit early and commit often. If we're practicing atomic commits, we're going to get a way more granular, we're going to get a more granular insight into what's changed, why it changed, and it's going to make reverting code, if needed, far less painful. It's not, hey, let's wipe out this day's worth of work, but rather, hey, let's remove these 4 lines that changed because it turns out we misread the spec. Do not be the person who just kind of does, oh, it's 5 o'clock, so git commit -m, checking in today's work before happy hour, #YOLO. Because if you do that, I will find you and I will scold you. So please do not be this person. Similar to atomic commits, we have atomic pull requests. PRs, like their commit counterparts, should be as small and as reasonably possible. We don't want a pull request for like every little single commit. Like, this pull request changes 2 lines of code, but it also needs these other 8 pull requests for it to make any sense. But there's a big difference when we're reviewing code, doing 10 small pull requests with a few changes each versus one giant monolithic pull request that takes like an hour and a half of totally focused heads down time to get through. Smaller PRs, as a result, are then going to lead to faster reviews. This shortens your feedback loop. It makes it much more likely if you push out a PR and someone's able to grab it in the 5 minutes they have between meetings. It's not going to be this, well, I'm going to put it off to the end of the day, and then, oh, the end of the day got away from me, so I'll get to it tomorrow, but then I didn't have my coffee yet, and suddenly it becomes like several days before you get feedback. Now, when you have more yet smaller pull requests, sometimes it can be kind of difficult to keep track of the order. What needs to be reviewed first, what branches depend on existing branches, all of that. I found that it's really useful using a label or a tag within GitHub of blocked. So my pull request might have text saying something like, well, this pull request introduces whatever feature, and then we can use GitHub will recognize fixes number 17. Once this PR is merged, it'll close issue number 17. Blocked is more of just a convention. It's not something that GitHub officially handles. But it tells my teammates that it's not worth looking at this pull request until we've taken care of number 42. Whether 42 is an issue or maybe another pull request, we can kind of say, hey, this depends on that being merged, so focus your attention there. It gives us a nice way to kind of say, these are the ones that we can tackle, and these are the ones that we're waiting on something. Similarly, we have the convention, and I think GitLab actually does some cool stuff with automatically flagging things that begin with WIP in the pull request title. WIP is short for work in progress, and it's a convention for, hey, I've opened this PR, maybe I want to solicit some early feedback, or I want to be able to keep track of notes. This one is going to be blocked by this, it depends on this branch, it has these dependencies, whatever. But it's not necessarily ready for a full review. Even if someone goes through and reviews it, it's not going to be ready for merge. So this is a great way if you want to be able to have a good ongoing discussion or have sort of a rolling, oh, I'm updating all of the documentation. As commits get pushed, I want people to be able to come in and comment and make sure that like everything makes sense. And when you're dealing with more complicated branches, this is a great way to help keep track of changes and keep notes specific to those branches. Again, if you're doing things that are, for instance, blocked. When it comes to coding standards, determine what coding standards you're using at the beginning of the project. And if you're not familiar with the general idea of coding standards, basically these are the rules saying, we're going to put our braces on the same line as the function declaration versus on a new line. We're going to use tabs instead of spaces. We're going to use camel case instead of snake case. All of those little can be seen as kind of nitpicky things, but especially if you're writing code to be distributed or to be integrated with other systems, it's definitely nice to be consistent. And if your team is all writing to the same coding standards, you're going to run into fewer merge conflicts and an overall more readable coherent code base. So pick a standard for each project and try your best to stick to it. If you're writing a WordPress plugin, especially one that's going to be distributed, WordPress has its own coding standards. Compare those to like PSR2, the PHP standard recommendation, I think is what PSR stands for. But this is kind of like all of the big PHP projects. They're kind of coming together around PSR2. You have Pair, which kind of predated PSR. You have proprietary team things where people are like, well, this is how our team does it. Maybe it's loosely based on one of these standards, but it's its own thing. In your coding standards, determine what's important in there and what gets reviewed. And then above all else, make sure that when you're enforcing coding standards, you're being consistent. One nice way to keep things consistent is an editor config file. This is a dot file, so it'll be hidden from most people, but dot editor config it's a standard that lets us set, this is how my editor or IDE should handle white space, how it should handle line endings. Are we automatically stripping trailing white space? Are we saving everything as UTF-8? Are we using spaces or tabs? All of that stuff. There are default files available for all of the most popular standards, and you can read a lot more about that at editorconfig.org. Then we have tools like ESLint. ESLint, JSHint, there's a whole series of JavaScript tools there, but they're great for ensuring consistent JavaScript. They're going to let you define the standards, what's important, the white space, the formatting. Do we want to make sure that we don't have any variables that are undeclared, or that we're declaring all of our variables at the top of the function, whatever. So ESLint is great for that stuff, and it's also going to catch a lot of the common performance and security issues. It'll be, hey, are you aware that you have, you're referencing this variable in the global scope that could be leaking data outside of your closure? So ESLint, super great tool if you're doing a lot of JavaScript, eslint.org for that. On the PHP side, we have PHP Code Sniffer by a team called Squiz Labs. It's a great tool for analyzing our code. It works by tokenizing and then analyzing the code against a set of coding standards, which are defined in a phpcs.xml or phpcs.xml.dist. So if you've ever worked on a PSA or PHP project and seen these files and been like, WTF, that's for PHP Code Sniffer. And PHP Code Sniffer is really great at catching some of the small stuff, that low-hanging fruit we were talking about earlier. Things like white space or naming schemes. This function is using a camel case naming scheme, but our standard says we're going to use snake case. You can set it up to configure or to catch missing documentation. Hey, we said every function has to have a doc block, but you just submitted code without one. Again, that low-hanging fruit. But if you have PHP Code Sniffer catching it, ideally as part of your continuous integration pipeline, you can actually get that feedback to the person as soon as they open the pull request, but before you as the reviewer even need to look at it. If they kind of go, hey, tests failed, you need to fix this stuff before the reviewer gets in there, you put yourself in a position to see a much better kind of starting point. So a very simple function here. Let's pretend we were writing this for WordPress. We're using the WordPress coding standards, dropping it in a WordPress theme or a plugin. So it's a simple function that defines a string message, and then it just echoes the string. If we were writing it using the WordPress coding standards, what might be wrong with it? Well, if we run PHP Code Sniffer, PHPCS, using the WordPress core coding standards, it'll tell us, well, echo something is not in snake case. It should be, so try echo underscore something. Our opening brace should be on the same line. Based on the WordPress standards, the brace would be here, not down here. This is Egyptian brackets. Then the string something doesn't require double quotes. We're not doing any sort of interpolation in it. So there's no reason to wrap it in double quotes. We can just wrap put them in single quotes. If we were to take this same function and then run it through the WordPress extra, we pick up one more, which is all output should be run through an escaping function. So WordPress extra this feeds into the WordPress.com VIP. This is really a good standard if you're doing any sort of professional WordPress development. This is saying not just, here are the things covered in the main WordPress coding standards, but here are some more best practices, some security-focused things, some performance-focused things. So we can see that up here, we're just straight echoing the string message. We should be wrapping it in perhaps an escape HTML, or if it's for an attribute, escape attribute, anything like that. You may have noticed up here we had this PHP CBF can fix the 3 marked sniff violations automatically, and it can say, yeah, I can take care of these. That's coming from a tool called PHP Code Beautifier and Fixer, which ships with PHP Code Sniffer. Another similar tool is the PHP Coding Standards Fixer. Now, this was started by the creator of the Symfony PHP framework, and it's going to let you automatically clean up some of the coding standards. Now, it does perform transformations on your code. So A, make sure you're using version control, and B, use something like git add-p, which will actually let you see a line by line. These are the things that change as I stage them to commit them, to make sure that it's not doing anything egregious against the code. I usually don't let it actually change anything and instead just give me the report. You can basically say, do a dry run, but it'll tell me, hey, you're importing these namespaces, but you're not using them. Or, these aren't matching coding standards, or your white space is messed up here, or any of those sorts of things. And that package is available at cs.semciolabs.org. As you research code review, you'll often find a number of services selling, quote, automated code reviews, because no one has the time, right? We have all those arguments against code review we saw earlier. So what can you as a team do to save time on code reviews? Most of these tools are doing what's referred to as static code analysis, where they're taking your code, they're analyzing it, they're not actually executing anything. There isn't a person behind the scenes or anything. It's just kind of looking, it's going a little bit further than like PHP Code Sniffer would be, but it's trying to find where there might be bugs in your code. It's really great at satisfying some of those does it work well type questions on that priority. Does it work? Does it work well? It won't actually be able to tell you, does it work? Save for, syntax errors or anything like that. But it's not running your code and saying, does it satisfy this requirement? But it is going to catch some of the, hey, you're doing this, but you're not escaping, or you're doing this, and this is a known anti-pattern when it comes to writing SQL queries, because this could cause infinite loops or whatever. So it can be a great addition to your team's code review practices, but I would not consider it to be a full replacement. If you recall, code reviews can also reduce the bus factor, and if Code Climate knows all about your code, but no one on your team does, you've done nothing to reduce said bus factor. The .gitignore file, hopefully everyone's already taking advantage of this, but this is another file that can be versioned with your repository, and basically says, hey, Git, ignore things, these particular directories or files. So things like node modules, vendor, things that we don't want to check into version control. By not checking them in, A, because they're already versioned elsewhere, and we're adults using tools like Composer to pull them in, the more code we exclude, the less code will be in the repository to be present in pull requests, the less will have to be checked, the less will have to be reviewed, the less people are going to have to kind of work their way through. If you're using a good continuous integration or continuous delivery pipeline, you'll also want to make sure that you're keeping compiled assets out. Technically, those are artifacts of a build. We don't need someone having to even skip past the, scripts.min.js file. You can't reasonably expect someone to code review a minified JavaScript file. So if we can keep it out of the repository, it's just less clutter, less noise. With Git, we also have the ability to use Git hooks. Now, these are points throughout the Git lifecycle where you can execute different scripts. A really popular one would be on a pre-commit hook, where you could say, hey, run all of this through our coding standards check through PHP Code Sniffer or whatever to make sure that it meets our coding standards. And if it doesn't, reject the commit. So people literally cannot commit code that doesn't meet the standards. These can be really helpful, but it is important to know that they're not stored within the repo by default. So it'll be stored in your local copy of the repo, but if someone else clones the repository, they're not getting those Git hooks. There are some tools to work around it. I have one that I've been meaning to finish called SME. That's a composer package because, of course, hook and SME, haha, it's a Peter Pan reference. But Git hooks can be an extremely useful tool if you set them up properly within your projects. One such example would be a tool that I wrote called WP Enforcer. If you're writing WordPress themes or plugins, this actually came about when I became an engineering manager at 10up, and I would have to do more and more code reviews, and I was sending a lot of code reviews back for things like, hey, you're not sanitizing this input, you're not escaping this output, all of those low-hanging fruit things. So I wrote a composer package that also has a post-install command that you set up in your project, and it automatically sets up a pre-commit hook for the user as soon as they run composer install. So they're getting whatever dependencies they need, plus they're getting a thing that says, hey, this isn't matching our WordPress coding standards. You missed escaping on line 14, and we'll reject the commit. So this cut down tremendously on the number of, or the amount of back and forth that we had to have during code reviews. Although I'm not going to lie, it did make me a few, I won't say enemies, but some people were definitely annoyed because they were more of the, let me commit my crap and let someone else deal with it. We would have caught it anyway, but they got kind of annoyed that we cut them off before they could push crap. Next, we want to make sure that as we're doing our code review, we are also reviewing our documentation, especially the inline documentation. We want to treat it as code. This is going to help help reduce what's known as doc rot. When, say, you have a function and the arguments have changed, but the documentation is still out of date. So suddenly someone's like, well, I'm going to look at the documentation to see how to use this. And it's saying it takes an array, but now it's yelling at me because it's expecting an integer. And it's like, I don't know how to handle this array. So especially when like a function or method signature is changing, make that an immediate rejection for the code review if the documentation has not been updated as well. Don't let the bad docs get merged, and you're going to make some great strides at reducing your technical debt by not having these old, rotten, inaccurate pieces of documentation. And finally, I know this has kind of been a fire hose, right? Most tools for analysis are going to let you whitelist things to be able to say, yeah, I know that's not normally safe, but it's okay. We've already checked it out. We've explicitly reviewed this, or we know what's going on. We accept the risks here. But if you're not periodically going back and auditing some of those exceptions, you may find cases where you have 100% code coverage and all of your tests are passing, yet there's still this pretty fundamental thing that's broken, and you can't quite figure out why. And then it turns out, oh, it's been broken, but someone basically said, hey, PHP unit, go ahead and ignore that. PHP code sniffer, yeah, don't worry about it. And it's really easy to get to 100% test coverage if you just skip everything that's untested. But that's not a particularly effective way to approach a code base. So when you run into kind of some of these weird, obscure bugs, or just this general, parts of your bug sweep or release cycles, make sure that you're auditing the things that people have said. Don't worry about these to make sure that you do not, in fact, need to worry about those. With that, I thank you very much for coming to this webinar. Again, I'm Steve Grunwell. I blog occasionally at stevegrunwell.com, work at Liquid Web, and again, the copy of the slides are available at stevegrunwell.com/slides/code review. And if it's okay with the INN team, I'd like to open it up to any questions that might be a thing.
Yep, let's go for it. So does anyone have any questions? Feel free to unmute yourselves.
Well, that's easy.
No one has any questions. All right.
Well, great. I'm going to stop sharing my screen here.